Thank you very much. Yeah, I'm Adrian, as we just found out. I work at ChainGuard, so I sometimes call myself a technical community advocate, which was your suggestion, Liz, because I'm not a huge fan of the term DevRel, but that's fine as well. And I'm going to be talking about Wolfi, which is our Linux distribution, why we built it, and how we built it. So at ChainGuard, we wanted to build secure container images, as in container images with very few known vulnerabilities in them. So we first built a Linux distro, as you do. And the obvious question is why? Why on earth do you want a Linux distribution if all you want to do is create secure containers? By the way, does anybody know where that image is from? Yeah, somebody said it, Babylon 5. I was wondering, it's pretty old school now, I guess. Yeah, and to understand this, not Babylon 5, why we built a Linux distro, it's best to take a step back and look at what people are currently doing to create secure container images. Or secure and minimal, I should say. So one thing you can do is use the Scratch image. So if you've worked with containers at all, Scratch is basically the completely empty image with nothing at all in it. So one of the most secure things you can do, and it is possible in some cases, is to build an application and just to copy it directly in to the Scratch image. And that way you know there's nothing in that image except what you've put there. There's no extraneous third-party dependencies, and so on. And this is viable in some cases, especially where you can create a statically linked binary and you don't have any need for some other things. But those projects are very much in the minority. What you'll find is that most Unix applications or Linux applications expect a few more things. Number one is TLS certificates. So typically, most container images are going to require TLS certificates if you want to talk securely to other web applications or websites, etc. You also typically need things like /temp, if you want to create temporary files, or /home, and you might need a user created, and so on. And that's basically what the distroless image gives you. So have some of you heard of like Google Container Tools distroless? Yeah, a few of you, that's good. So distroless is basically a really stripped down form of the Debian base image. It's smaller than Alpine or anything else. It's only a few megabytes in size. It doesn't contain a package manager, and it doesn't contain a shell. So some of the things you expect to find in other images, it doesn't have. It really is completely stripped down. And there is sort of various base images or distroless images for different ecosystems, if you like. So there's a static image for putting your statically compiled binaries in. I think there's also a Java image, and there's also a Python image. But that's about it. Now, Google Container Tools distroless is based on Debian. So theoretically, you would like to say, well, actually, my application also depends on this other Debian package. I'd like to put that in there. But that's not that easy. There's no package manager in there, so you can't use a Docker file. It is built with Bazel, so theoretically, you should be able to modify the Bazel and add in the package you need and create your own distroless base image. But in reality, it's not so easy, largely because you've got to understand Bazel and fight with that to get anywhere. So it is a bit difficult to extend. So to give a bit more background, Google distroless was actually created by Dan Lawrence and Matt Moore. I just realized I've not actually explained who's who here. So and then I was about to say the one with the hair, but they both got hair. The one with the curly hair is Dan, and the one with the sunglasses is Matt. But Matt Moore and Dan Lawrence created the distroless project when they were at Google. They then left Google and started the company ChainGuard, which is where I work. And so one of the first things they wanted to do at ChainGuard was to sort of continue the distroless, or create V2 of distroless effectively. To do that, they hired Ariadne Connell, who has a background in Alpine. And she has really been the force behind Wolfi and where we've got to with secure container images. I do need to say Ariadne has since left ChainGuard, so she's now working at a stealth startup, so I'm very curious to see what she does next. But one of the first things Ariadne did was built APCO or APKO. I'm still never sure how to call it. So this is before we'd even started work on Wolfi. At this point, we're still using Alpine. And what APCO does is it takes a bunch of APK packages, the Alpine package format, and assembles them into a container image. And that's really all it does. So it's kind of like Docker build, but it's a lot simpler. You can't run arbitrary Linux commands. You can't even put files in it. All you can put in it is Alpine packages or APK packages and set metadata for your container. Now, that means there's a lot less you can create, but it also means it's much more simpler, and that simplicity means we can make it reproducible. So you run APKO twice, you get exactly the same object out. And it's easy to create an image without a package manager or shell, because effectively our package manager is outside the image creation process, if you like. So that's an example. I wonder if my thing will work. There we go. So in this example, we can see we have to specify the repository we're interested in. In this case, we're using Alpine. We specify what packages we want, and we specify some container metadata, and that's it. So this will build you a container image with Alpine base and whatever my package is. And that's it. The other tool we built was Melange. So we have APCO to create our images, and we have Melange to create APKs that we're going to put in our images. We could have used Alpine APK tools, but we wanted something a bit more modern and pipeline-oriented. And so we built Melange. Melange is sort of designed to be pipeline-oriented. It's sort of inspired by things like GitHub Actions and also designed to work alongside things like GitHub Actions. Last talk was on SBOMs, so you will be happy to hear Melange does create SBOMs as it goes. So those SBOMs are getting created at build time. They're not like SBOMs created by some other tool, which gets created by interrogating the package manager after it's created. OK, we'll see if this works. We'll try and open an example, just to give you an idea of what it looks like. And that worked. It's going to be too small. So I don't want to talk too much about this, but this is Melange. And it's really just a way of building a package. So we're saying what dependencies the package has and how to create it. We use like a pipeline. So fetch is obviously going to grab your sources. Then we call make install, and strip to take out the debugging symbols. One important thing is actually the sub-packages. So we can split a package out into multiple sub-packages, which is nice because then you can only take part of a package that you're interested in for your other application. You don't have to like have a whole huge package for one small dependency or developer headers or something like that. I'm not going to go through the rest of the examples. And once you have Melange and the ability to create APKs, or APK packages in a scalable and maintainable fashion, we then started thinking, well, how much further, how much more work is it to create a Linux distribution? And you start thinking, well, maybe it's not that much more. And if you start looking at Linux distributions like Red Hat and Ubuntu, they haven't really evolved much in the last, I was going to say decade, but I guess it's a couple of decades. At least 3 decades. They were really designed originally for running on hardware servers or racks or home computers. And you would typically install it via CD or floppies, etc. And then, of course, we jumped to VMs, but that didn't really affect the Linux distributions too much. It was still largely the same idea. But now I think with containers, I think things have or are evolving. And our existing distributions, they're kind of starting to creak a bit. So in a container, we're generally running a single application. So you need much less stuff. You don't need all this Linux operating system. And also static binaries tend to be a much better solution than having everything dynamically linked, which is another departure from typical Linux distribution. And so we kind of realized there's a lot of advantages to having our own operating system if we're going to build secure images. And we naively thought it wouldn't be too much more work based on where we were. Because 90% of a Linux distribution is really just package management and distribution. But if I'm being entirely honest, I think there's also a large part of at least Ariadne that wanted to see if we could do it, if we could actually build our own Linux distribution. And so that's why we created Wolfi, or how we created Wolfi. Wolfi is named after the world's smallest octopus, because it's used to create small images. We use the term undistro sometimes. So I'm saying we create a complete distribution. There are still some things missing, most notably, we don't create our own kernel. So we use the kernel from like the Docker host rather than supply a kernel. In Wolfi, everything's compiled from source. It's all compiled against glibc, which is a departure from how Alpine does everything. And so although we use Alpine's APK format, Alpine and Wolfi are not like cross-compatible. You can't put Alpine packages inside a Wolfi image and vice versa, largely because of the glibc versus muzzle thing. We do try to bootstrap things. So there's a really good blog post on the ChainGuard site about us bootstrapping Java, where we went back to like a really early version of Java, used that to build Java, then you use that to build the next version of Java, and the next version, and so on. So you've got a sort of the full lineage there. And so what were the benefits here? Well, one of the main benefits is that we immediately had a distribution that used the APK format, but was compiled against glibc. So we don't have some of the complaints that sometimes the Alpine project gets about incompatibilities with muzzle. But perhaps the biggest advantages are that we control how quickly packages can be rebuilt from upstream updates, and how quickly those packages can be turned into new container images. And we can also, because we have our own operating system, we can also issue security advisories that get picked up by security scanners, as I'll explain more in a minute. By the way, I did become a father recently. This isn't my kid, but I did realize after I was using this image, and like the kids might be going, yay, but then you realize all he wants is picked up. But, yeah, anyway. Now, anyway, to understand why a bunch of these things turned out to be important to building secure images, we're going to need to take another step back and look at where we are in terms of security in the container ecosystem. So if you've used containers at all, I bet you've come across vulnerability scanners. So have people heard of things like Trivy and Sneak and Gripe? A few nods. OK, so hopefully you're all on the same page. It's also Docker Scout's really nice. That's one with Docker. But Trivy and Gripe are both free, and what's the open source? I believe they're both open source. Anyway, vulnerability scanners will take your container image. They'll make a list of all the software inside them, a bit like an SBOM, and the versions of said software. And then they then compare that list to various security databases. So like the output from NVD and things like that. Also the output from various Linux distributions and so on. And then they return any known vulnerabilities that they believe are still in that image. So this sounds great. The sort of theory sounds amazing. Now I should be able to scan my image, find any vulnerabilities, get rid of them, and ship to production vulnerability free. But the reality is not so much fun, and it's nowhere near that. And the problem is that nearly all public images have vulnerabilities, and nearly all base images have vulnerabilities. So you start from a point of having vulnerabilities, and you can never get to zero vulnerabilities. So this is the result from running gripe on Redis. This is from like last year, but I did run it again this morning, and I get sort of roughly similar results. I think it's actually 8 critical, it says at the minute. So at the time I ran this, this is the Debian version of Redis. If you don't specify a tag, then it's going to grab latest, and latest is the version of Redis based on the Debian operating system. So in this image, we can see there's 109 packages. I think there's maybe 111 if you run it today. And it picked up 7 critical, 36 high, 32 medium, 6 low, and 126 negligible CVEs. Now, the vast majority of those are probably not real CVEs. Some of them will be disputed by Debian, and you'll see you can run gripe and it'll mark a bunch of them won't fix. And that's basically ones the Debian team have looked at and said, yeah, we don't think this is really a vulnerability or serious enough for us to bother investigating. But at the same time, how do you know? Like, how do I know one of those isn't going to result in my whole application, my whole system being attacked? You do get much better results if you run gripe on the Alpine version. I'm not quite sure what it says if you run it today. It might be much closer to 0. I'm not sure. But at the time I ran this, it did pick up it says 2 unknown CVEs. Also note there's much less packages in the Alpine version. So it's a much smaller image. There's much less in there. And that's one of the reasons there's less CVEs, because there's just less packages to have CVEs in them. And then I ran it on the ChainGuard version, and that does report 0 vulnerabilities. So we're doing significantly better than both Debian and Alpine. And there's a few different reasons that we managed to get to 0 in the ChainGuard version. One of them is like the minimalism, so the diskless approach of like cutting everything out, including like the package manager and shell if you don't need it. But the other things that have to do with stuff like release cycles and security advisories, which I want to go into a little bit here. So here's like how updates happen in like Debian and Alpine. Say the upstream projects, or your Redis, your Nginx, your MongoDB, or whatever, they release a new version. That new version has to be picked up by Debian or Alpine. They have to create a package from it, and then that package has to be built into an image by the Docker Hub or whoever is creating your image. And what you will typically find is there's like a 1 to 2 week lead time between a patch or a new version being released and that becoming a container image that you can download. In Wolfi, we really short-circuit that because we both control when a new package is created and when a new image is created. We can like release a new image within like 1 to 24 hours of a new release or a patch being released. So that's a big difference, going from like 1 to 2 weeks of potential CVEs being there to like 1 to 24 hours. We also sometimes have to apply patches. So sometimes you'll find that upstream might not do a new release just because there's been some change or some CVEs or something. And a typical case where that might happen is if it's not in the source code of the upstream project, it's in like a transitive dependency. So it's in something they depend on and pull in, but it's not in their actual code. So they don't want to do a release because there's nothing new to put in a release. So what we can do then is update the transitive dependency ourselves and do a new release ourselves. But the problem is we're still on the same version of the code as upstream. We just patched this dependency. So we need a way of telling like security scanners, OK, we are using version 1.27.1, which is the same as upstream, but we have also patched this vulnerability, if you like. And that's where security advisories come in. So try and explain this. Here's a scan from months ago now of the Alpine Redis image. A note that mentions 2 critical vulnerabilities, the 0543 and 3734. And when I scan, and so security advisory is basically YAML for scanners. If you go to this website, you can see all the advisories for Wolfi Linux. And it looks like this. So this is literally a snippet from our Redis security advisory. And so what we're saying here is, OK, if you think, if you're looking at CV 2022-0543, well, that does not affect the version of Redis in ChainGuard from version 7.07R0 and on. It actually, I don't think, ever affected it, but that was when we issued this advisory. Now, I'll go back, actually. Now, the question is, well, why did this disappear in Alpine? Why didn't Alpine say, we don't have this vulnerability? And the reason is they couldn't, because if you see the type here, it says type binary. It's not type APK. So Redis in the Docker Hub Redis image is not installed via APK add. It's installed by building it from source and copying the binary in. So Alpine can't say anything because it's not their package. Docker Hub can't say anything because they're not a Linux distribution. So there's no way, there's no sort of organization to release security advisory for this. OK, this will hopefully all change with Vex, but that's not really a solution just yet. And that explains why this vulnerability shows up in Alpine, but not in ChainGuard. I will say that I don't think I did briefly look at this vulnerability, and it was to do with packaging, I think, in Debian. So it never affected Alpine. But they still can say this vulnerability isn't present. So what does Wolfi give us? Well, it's a glibc-based recomposable package system for building minimal images. So we can build images without package managers and shells and so on. The fast update cycle is also critical to what we do and we get, and being able to get updates immediately from upstream projects and release them, and also the ability to issue security advisories. How am I doing for time?
7.
Oh, cool. I'll go through this briefly then. So a few other things that we can look at. Reproducibility. So that's one thing that's been very important to us. So if I come back to AppCo, here's another AppCo, this time using Wolfi instead of Alpine. Again, very simple idea. All we're doing is creating an image with these two packages, CA certificates and Wolfi base. If you build this, basically you'll end up with what's called a Wolfi base image, which is really just a BusyBox shell and not a lot else. And we're also setting the entry point. But the key thing is, if I run AppCo, which is our build tool, on this YAML, it will generate a tar file. That tar file you can take and you docker load left arrow, what's that called? Less than sign. And you can load that directly into Docker if you like, or you can send it to a registry. And AppCo actually supports, I think, directly uploading things to registries. But anyway, if I run SHA-SUM on that tar file, and then I remove everything and run it all again, I end up with exactly the same tar file to the bit. And that's actually not something that's that easy to do. You can't do that with Docker build. Or it's certainly very hard to do with Docker build anyway. There is work on making Docker a bit better by allowing you to do things like force timestamps and stuff like that. There is a minor caveat that I should mention. If I run it twice and these packages have been updated in between, you will, of course, get something different. It is possible to pin packages, so you can specify exactly which version of packages you want. And actually, if you go into Wolfi Linux, you can download an attestation, which gives you the AppCo file with everything pinned. So you get the exact AppCo file that should generate exactly the same image. One of the other things we spent a lot of time on is like automation and updates. So the thing is, ChainGuard is not a huge company. We only have, I don't know, 30-odd engineers. And for that reason, we have to use a lot of automation to try and keep up with all the projects releasing updates all the time. So basically, we have a cron job. I've written hourly. I have no idea if it is still hourly. And it goes and checks, hey, what packages have been updated? And we rely on something called releasemonitoring.org. So I think that's from Fedora. Basically, it's a huge database of projects that get updated and lets you know when a new release has happened. And we also use GitHub updates. So obviously, a lot of software is now on GitHub, and GitHub is actually pretty good about APIs and let you know when a project does a new release. GitHub's actually a little bit nicer, to be honest, because it gives us a bit more metadata about the project, including stuff like commits and release notes. So if you go into Wolfi on GitHub and you look in some of the source files, like the melange files, you'll find this rather cryptic looking bit at the bottom, and the update bit is all about this automation. So this is basically saying if the identifier 1557 on the releasemonitoring.org gets an update, then update this melange file. And our automation will go and create a PR automatically. And this is very similar for the GitHub updates. Quite often, we have to do a bunch of munging around versions, because not every project uses the same version number, and sometimes it's in different places in the string, and sometimes there's a V before it, et cetera, et cetera. SBOMs. So all our packages do come with SBOMs. They are created at build time. They do tell us exactly what's in our images. The key thing, though, is at the build time point. So there's some of the most famous tools for creating, or commonly used tools for creating SBOMs at the minute, create them by looking at the package manager. So they'll go and ask Debian, hey, what packages are installed? They go and ask APK, hey, what packages are installed? And that's how they create a list of software in your image. So they quite often miss stuff that's been copied in and things like that. Not always. So I think they've got a bit better. So some of them will pick up like Go binaries and things like that now, but that didn't used to be the case. But the point is, creating a build time is a much better way to create your SBOM because you have more data available to you. Yeah, so in summary, we built Wolfi because it seemed like a good idea at the time. And honestly, it turned out to be an excellent idea. I don't think ChainGuard images would be anywhere near a good product if we hadn't created Wolfi. It is a community project. So if you go to wolfi.dev, that'll take you to the GitHub page. And you can, PRs are welcome. And there is a community site. But yeah, that's pretty much it. Thank you very much for listening.